Hello, welcome back to the channel. So in this video series we are going to be looking at some of the exam questions from 2020 until 20 or all the way back to 2018 basically. So let's look at the first one. These questions are from paper 1, question 1.3 for all those years from 2018 to 2021. I haven't seen the one for 2022, that's why it's not included in this series. Hopefully we're gonna see it at some point. So let's look at these questions. Apparently they are interesting, which is some of the reasons why most students will spend so much time in them. So we are given the one in 2018 where they say if x exponent 9x, it's actually equals to 64, and we also have 5 exponent the square root of p, it's also 64. Calculate without the use of a calculator the value of this expression there. So we are basically given two equations, and we are required to calculate the expression from those equations. They must help us to be able to evaluate that expression. But what the trick is, we are supposed to show that we did that without using a calculator, you see. So you look at the two expressions. We can try to solve them for p or x, but if we solve for those, it's just gonna be clear that we actually used a calculator, and the trick is to maybe claim that we didn't use a calculator. Look at the one on the right hand side, this equation on the right hand side of 5 exponent square root of p equals to 64. That is very so similar. The left hand side of that equation is so similar to the denominator. So the only difference is that the 5 doesn't have a square root in the equation. So the first thing we can do, just take the square root of both sides, and then it will be exactly the same as the denominator. And then we won't need to solve for p, but we'll have the expression or the value of the denominator in the expression that we are required to evaluate. So let's do that. Just gonna do this exponent 1 over 2, because exponent 1 over 2 basically just means I'm taking the square root of both sides. Yeah, the reason I'm doing it this way is so that you can see something. Just hang in there how we end up introducing the square roots thing. So 5 exponent that's basically when you remove the brackets, it's going to be 5 exponent this, like that, and then 64 exponent 1 over 2, like that. That's basically 8. So this is, you are still applying the rules of exponents. 5 exponent, if you think of a exponent b like that, p like that. Actually, let me just stop what I'm trying to show you and just continue the question. I hope you can see how this is basically the square root of 5 exponent square root of p. If you can see, that's when I'll be required to do what I was trying to do to try to explain, but I hope it's clear that is actually, from here you actually come here, that is actually equals to 8. So we know what the numerator is. It's actually equals to 8, so that whole numerator, can replace it by 8, then we are fine. As for the denominator, I kept saying numerator and I meant to say denominator equals to 8. As for the numerator, we need to find how we can replace it by a simpler version from this left hand side equation. So let's try to do that. With this left hand side equation, I'm just going to create a bit of space. With this left hand side equation, what we can do, because look at the numerator equation or expression, in the expression that we're eventually required to evaluate, it has 3 exponent x. So we can already do that, so that we end up with some 3 exponent x equals to something. We just hope for that if we can simplify further. My handwriting is bad. Okay, let me see if I can do this, reduce the thickness, because you are struggling to see what I'm writing here. No, that is bad. Let's try this. That works. So 68, that's basically 2 exponent 6. Okay, let's see where we can get with this whole thing. Okay, let's try this. 3 exponent x, I'm just trying to eliminate that 9 basically, so that we have 3 exponent x equals to something. So to eliminate that 9, we just have to say something like this, 1 over 9, and then 2 exponent 6, also exponent 1 over 9, like that. I hope we can do that. If we can do that, this 9 will cancel that 9, then we're left with 3 exponent x, like that. Okay, I just need that, make the writing a bit neat. So this side we're going to be left with 2 exponent 6 over 9. 2 exponent 6 over 9, what's that? Surely it can be written as like a simpler value. 3 times 2 divided by 3 times 3, that's like 3 over 2, if you can see. I mean 2 over 3, not 3 over 2. Yeah, 2 over 3. Yeah, I'm just trying to clear my handwriting because it's bad. Yeah, sorry for that. Yeah, so basically we can replace that 3 exponent x by 2 exponent 3 over, 2 over 3, like that, and then we replace the denominator by that, replace the numerator by that, and then we try to simplify and see how far we can go. So let's try that. Now we are going back to our expression that we are required to evaluate, right? Okay, square root of 5, square root of p, like that. This is going to be equals to, the numerator already is 8, the denominator is 8, the numerator, that 3 exponent x, let's try to simplify first and see how far we can go. See, 3 exponent x minus 1, when you remove the brackets, we're just going to multiply the whole exponent by 3. So this is basically where we're going to be, 3 exponent 3x, the 3 exponent, what is it, negative 3, like that, divide by 8. Actually, we didn't have to go like aim for 3 exponent x. We just had to aim for 3 exponent 3x when we're simplifying this piece, or rather I can say this piece, or that equation there. So that would have helped the question, the problem better than what we aimed for. So okay, well, I've done the question before, so I just wanted us to figure it out together. So that means we're actually supposed to move from 3 exponent 9x equals to 64. Let's try to aim for 3 exponent 3x, because if we can replace that by some value, then we are fine. So let's do this. 3 exponent 3x, wait a moment, that's, anyone who knows how to deal with this error, guys, they can assist. I hope you know what error I'm talking about. If you don't know, it's fine, let's leave it. 64, that's basically, you can just leave it as, what is it, that's like 4 exponent 3, that's 64. We have already established that, I think, before. No, we haven't, but 64 can be written as 4 exponent 3, like that. Now that you have powers with the same exponent, you can know that the basis of those powers, they are equal, like that. So 3 exponent 3x equals to 4, so we can replace that here. I hope you see what I'm saying. 3 exponent negative 3, or divide by 8. Okay, now this shows that we actually didn't use a calculator. If we were to try to break down this whole thing to 3 exponent x times, or something like this, 3 exponent what is it, x and 3, like that, with the aim of maybe trying to come and say we're gonna substitute that which we had there, I don't know if we'll come across as if it's there that we just use a calculator, because this is going to be something like this. What is it, 2 over 3 exponent 3, like that, and then what is happening is that we have 2 exponent 2 over 3 times 3. This cancels that, then we are left with 2 exponent 2, which is equals to 4. So basically there's 2 ways then in which you could have went about this. It was still going to work, and then after all the whole simplification, you can then come back here and just, eventually you're gonna end up here, because the whole thing is gonna bring you back to there. So once you have that, all you need to do now is just to simplify. And the idea is to not use a calculator. So 4 over 8, that's 1 over 2. Okay, that's 1 over 2. And then 3 exponent negative 3, that's actually 1 over 3 exponent 3. I hope this whole garbage is not disturbing you. Okay, I'm just trying to simplify here. 1 over 2 times 1 over 3 exponent 3, that's 27. You don't need a calculator to know that. You have done many questions, so I'm sure the B8 can believe that you know what 3 exponent 3 is without using a calculator. So 2 times 27, that's just 27 plus 27, which is 54. So we are done with the question. I don't know. I had to do some of the rough work with you guys so that you get to see the whole thinking process that I usually go through when I do these kind of questions. I would have just tried to come with some clean work and then present it to you, but I hope doing it this way, going through the rough work with you, eventually coming out with the solution, it helps you understand better than me just presenting a clear worked solution to you. Because I mean, we all have that in the memorandums. So okay, let me know if that actually helps you. Maybe we can adopt that kind of, maybe presenting some problems going forward. If it's unnecessary, yeah, we just present some clear solutions and then we keep it moving. Okay, see you in the next video.